The top two, definitely, the number one for me would be the rise of agents as an AI architecture.
Mm-hmm.
And so agents is just a fancy way of saying that you have multiple models communicating with each other and sharing some aspect of what tasks or problems they're being asked to do with each other in a way that a group of different models can work together to answer a problem. The second answer I would give you is probably just coding in general. I think is becoming a really important
Mm-hmm.
area to focus on. We're seeing models that a year ago we were focused on just the single answer that model would give to a coding question. Help me write
Mm-hmm.
an iOS application. And the model would give like a pretty close to accurate answer, but often far enough that you'd still have to spend an hour, 2 hours as a developer using that output to actually make it useful to you.
Yeah.
But now I think with agents and other architectures, we're starting to see much more sophisticated ways of getting that insight out of the models. And we're seeing a lot more great outcomes for developers using those more sophisticated techniques.
Hi, friends, and welcome to this exciting episode of Leading with Data. Today, I have with me Vijay Karunamurthy, who is the Field Chief Technology Officer or CTO at Scale AI, where he works to demonstrate the capabilities of generative AI and large language models, partnering with several large model providers, governments, and Fortune 500 companies. Prior to Scale, Vijay was a director of engineering at Apple and Google, where he has worked on applications of AI for personalizing human interfaces. Vijay was also an early employee at YouTube prior to its acquisition by Google and led the search and discovery as well as collaborations with media, entertainment, and several advertising agencies. He holds a BA in mathematics from University of Illinois at Urbana-Champaign and a MS in computer science from Stanford University, and an MBA from UC Berkeley Haas School of Business. So, Vijay, thanks a lot for taking time out from your schedule and looking forward to the discussion. Welcome to the show.
Thank you, Kanal. Thank you for having me on Leading with Data, and very excited to talk about large language models and the history of this field.
Great. So, Vijay, I would like to start with your education background. How did you get into AI or machine learning or data science, whatever that field was, and what are your early memories like about the field?
Yeah. I was very lucky in that I went to college at a time when AI was just becoming an interesting topic back in the early
Mhm,
'90s. And so
mhm,
I started to get interested in part because I was a biochemistry major as an undergrad, and I was interested in biology and how living things work. And so the idea of building a neural network to understand how living things go about doing the things they do was very interesting to me. So I ended up
mhm,
working on a neural network project, which is just a very simple project back in those days. I picked up a book that someone had written
mhm,
about neural networks, and I tried writing down the code. Back in those days, we didn't have GitHub. We didn't have other sites where you could just download all the code. So I had to write everything out by hand.
mhm.
But I really
Interesting.
enjoyed it. I enjoyed that aspect of thinking about learning and how you go about understanding patterns that you might see in data
Mhm,
by building this network that could learn over time. For me, it was just a really invaluable experience to getting started thinking about machine learning. Um, that it's just so happens after that point in time, there was what's called kind of a neural network winter where people stopped
mhm.
being interested in neural networks for some time. They
Oh,
just thought the
yeah.
technique was not scalable. So I spent a lot of my early career working on machine learning, but using other techniques, things like
Mhm,
SVD or other approaches that weren't as maybe as capable of neural networks as they scaled up, but were easier to deal with
mhm,
data at the scale that we were operating at the time. But once I joined YouTube in 2006, things became interesting again, in part because there was a huge amount of video being uploaded every day to YouTube. And so we spent a lot of time trying to figure out how to connect the dots, how to make sure that a new video uploaded was associated with a topic or some type of interest that someone might have, so that you could identify who would be interested in that video and help them see that video earlier on, whether that was through search or through recommended videos or through the homepage or other approaches that you could use to try to get that video in front of people. So in the early days of YouTube, a lot of what we did was based upon what people were viewing, and also based upon what users had written about the video. What was the video's title or description, and what happened in comments. But towards the end of my time there was actually interesting approaches that were taken using convolutional neural networks. And that was a really kind of eye-opening moment. The fact that you could see a little bit of what was happening in a thumbnail or in a frame of the video, and you could understand that this was a video about breakdancing, or this was a
Hmm.
video about Bollywood dancing, and use that to be able to figure out which of two different users would be interested in that type of video. Even though the video might not have any title or description, the user might have uploaded it very quickly without writing anything. You can still figure out enough
Hmm.
about the video to get it in front of someone. So for me, that was really exciting, and I ended up doing a bunch of startups with Chad Hurley and Steve Chen from YouTube, really focused on discovery. How do you find content, and how do you personalize the experience for users? And over the course of those years, I would say neural networks really started accelerating again. There was a lot of amazing work by Fei-Fei Li and Andrew Ng, and so we started to adapt these techniques to live video and other formats. So after that, at one of my startups with Steve Chen, we got acquired by Apple, and I got to spend time with the team there, working on really privacy preserving machine learning, of which Apple, I
Hmm.
think, is one of the companies that really respects a lot around which data needs to be kept securely on the device and what can you do with that data. And so it was a really interesting time to think about those techniques. There's also a range of different content that you experience on your phones, whether that's apps or videos or movies. So thinking about ways where machine learning can be applied to the discovery of that content was a really interesting topic. But for me right now, for the last 2 years, I've spent at Scale AI, and it's been kind of a whirlwind couple of years for generative AI. We, in part, became known for the work that we did over 4 years with OpenAI, where there was a
Hmm.
real need to find ways where human beings could understand what large language models were doing, and then help instruct those large language models on how to react in different scenarios. So, with the launch of ChatGPT is a great example of this. You suddenly have an LLM model that goes beyond search, and actually lets you type as a user what sort of outputs you want, and the model respects and follows what the intent is of a human being. That's kind of a brand new field and area that gets into a lot of issues around how human beings should interact with AI, and it's been kind of a core part of our work over the last couple of years.
Wow, that's so inspiring. And by any chance, do you remember that first neural net which you kind of built? Was it on your local machine? And then was it solving a problem? So what was the story behind getting into this neural network at that time?
Yeah, it ran on my local machine. It ran entirely on the CPU. I wrote it in C++. So at that
Hmm.
time, GPUs were in the early days of existing. This was before NVIDIA had released a standalone product, but you could get some GPU acceleration. But people didn't really see the value of that as applied to neural networks back in 1998, 1999. It wouldn't be for another 10 years that people really understood how you could accelerate using GPUs or TPUs, the work that
Hmm.
was done there. So at the scale that I could train it at then, I could only get to a couple thousand nodes. And I used a ReLU kind of activation function. But today, there's a lot more sophisticated techniques you can use and ways where you can distribute that training, all of which has been really important to the AI revolution over the last 20 years.
Interesting. And specifically at the work which you do at scale today, you've seen so many different approaches, right? So on one side there is, let's say, YouTube, which is trying to use every possible data on the cloud to, let's say, Apple, where everything is privacy uh, focused and privacy preserving, as you said. So how has that influenced your thinking and how you think about AI and responsible AI in general?
Yeah, the world of AI is evolving around a couple of different paths right now. On the one hand, you have the very large, what are called open API but closed source models. Those that are
Hmm.
run within large cloud providers. The big ones that OpenAI, Anthropic, have been evolving the size of their models over the last few years, and we expect that to only continue. Those models are often at a size and a specificity of the architecture that might be difficult for them to even try to open source it. Trying to run inference on a model that gets towards trillions of parameters starts to become very difficult for even the open source community to do. And so those models are growing and scaling dramatically. It's interesting for us as those models grow because there is what's called a scaling law of how you scale models as they grow. And one of the most famous scaling laws, there's one called the chinchilla scaling law that DeepMind published, which states as the number of parameters and the capacity of the model grows, the amount of training data that you need in order to optimally train that model starts to increase as well. So the number of tokens that you might use to pre-train that model. And there have been efforts to understand what happens also after the model's been pre-trained, and you need to start to do what's called post-training of the model, which is where human beings offer demonstrations or instruct the model and how to give the best possible answer, where there might be scaling laws there as well. If you have a model that's not just writing emails and poetry, but it's actually solving math problems and maybe solving coding problems and going even further, you may need much more post-training data to help that model understand how to unlock those capabilities. So that scaling is happening on the closed side. But at the same time, there's also a lot of interest now in what are called smaller language models. So those models that are more around 3 billion to 7 billion parameters, maybe all the way up to 30 billion parameters. And these models are evolving very quickly as well, in part because the open source community has really taken off over the last year and a half. So there are all sorts of libraries and packages now that you can use in order to train your own foundation model or maybe fine tune an existing foundation model and adapt that to different scenarios. So where that has become really interesting has been in the enterprise. So financial services companies like banks or healthcare companies, they actually have a lot of data that needs to be kept private. If you're talking about customer data or you're talking about sales patterns over time, that bank can't go and reveal that data externally. And so a large public model can't be trained on that data. And there may even be restrictions on whether those models can be fine-tuned on that data. But with these smaller models, you can run them in a variety of different data centers. You can run them on all the large cloud providers like Google or Amazon or Microsoft. And you can even deploy them on what are called on-prem data centers, or on your premise could be in a local data center or some place where you have secure access to the hardware. And these smaller models can be fine-tuned there and use a lot of private data, and you could put restrictions on who can access that model. So that's become a really interesting pattern, and we see that trend continuing over the next couple of years, where lots of different enterprises will take these smaller models, they'll fine-tune them for their specific use case, and they'll go even further and fine-tune them on their private data and make that available just to their employees or just to internal users.
And can you share maybe a example where you found this approach very powerful for any of your clients or solving a specific problem?
Yeah, absolutely. We have a great client that's a financial services company. And one of the interesting
Hmm.
things that they needed to do was be able to do data analysis at scale. So they have a large number of people that they hire to be data scientists. They are often writing queries against data. And those queries could be SQL queries if they're running against a Postgres or Oracle database, or it could be an unstructured query language if they're running against Cassandra or Hadoop data store, or it could be a business intelligence tool. So we need to help those data analysts do their job more efficiently in the future. And one of the things
Hmm.
that the bank worked with us on was the ability to fine tune a language model so that the model understands what makes a query more efficient in this environment. If it's a
Hmm.
SQL query, can I rewrite that SQL query to help it leverage an index that maybe the data analyst didn't know was available at the time they were writing the query? Or can I change what sort of tables I join against to make that more efficient? And if you give enough
Hmm.
demonstrations to this model of what the efficient queries have looked like in the past and what inefficient queries have looked like, the model can get really good at understanding those patterns. Should I change how I write the subquery in a given clause? Or should I change, how I refer to different tables that are user tables so that I can get just the right performance out of them? The models can also leverage something called RAG, which is
Hmm.
becoming the really important pattern of how you build AI applications today. RAG stands
Right.
for Retrieval Augmented Generation. And it's really just a fancy way of saying you do additional search to find data that's relevant to the model. So with RAG, you can go and query the database schema itself. You can look for what users tables might be relevant to this query. Or you could look for examples of joins that might be good to provide as examples. And you can pass those in a structure how you talk to the model about that data in a way that the model better understands what's happening with this particular customer and how they've structured their data over time. So using the computational techniques, we've actually created the ability to assist these data analysts and help them do their job much more efficiently. So instead of spending 30 minutes or an hour rewriting their query so that it's ready to run in production, they may only need 2 or 3 minutes because the model is able to help them with suggestions and revisions right there as they're writing the query so that they are ready to go and run that in production. And they benchmark that over time, and they've seen the queries actually improve dramatically as they've adopted this technique.
Interesting. And in this particular case, so there was a RAG layer to get the exact queries from the previous, let's say, snippets of SQL queries. And then there was a generation layer, or it was directly the RAG layer which was shared with the analyst.
Yeah, that's a great question. It's the combination of both that's appropriate. And actually, to break it down, the RAG layer has a couple of different components. One
Mhm.
might be going and querying a unstructured data source. So in this example, you could have schemas of databases. Those could
Right.
be stored in any sorts of formats. It could be stored in how DDL, the data definition language, specifies those schemas. It could be stored in JSON format. It could be stored in a variety of different formats. But what's important is being able to find relevant parts of that schema given a query that a user is trying to write. And that's a very
Mhm.
different search problem than what we've had in the past. If you think about Google
Right.
search or searching on your iPhone, you're typically typing the name of an app you're looking for, the name of a restaurant you're looking for. It's pretty easy to find examples of documents that match that name. So you're often looking for like a proper noun or something that specifies exactly what you're looking for, and you find that. With this type
Yeah.
of search, it's looking very different. You're giving an example of a query against a table. You need to translate some way to finding all the relevant tables and examples of queries in this other database without knowing exactly what the user is looking for. So that's a great example of what's called vector databases, where they can be made useful.
Right.
And it's an embedding space search instead of a more specific TF-IDF search. So
Yeah.
what we spent a lot of time on is thinking about how you structure that embedding search. How do you think about chunks of these schemas that you could specify in embeddings? How do you store those embeddings? And then additionally, we spent a lot of time thinking about how you re-rank the output. Once you
Mhm.
retrieve a set of documents that might be relevant, or chunks of documents, how do you re-rank those and specify to the generator model exactly what the context is that they should understand? Is this an example of a schema that's changed over time, and so you should only be looking at the most recent examples of these queries? Or is it an example of a schema that stayed pretty consistent, and so you can look at a wide range of different queries that have been run in the past? Being able to provide that specificity ends up being really important to getting accuracy in the model. But then time spent on the generator model is also important as well. And that's where you can fine tune a generator model to give structured SQL outputs or to give useful feedback to a human. Sometimes a combination of those two ends up being really important. But having really high quality generator outputs ends up being often the defining factor of an AI application.
And for a problem like this, what are the trade-offs between a smaller model versus a larger model, and how do they typically pan out in a situation like this?
Yeah, that's a great question. And actually, to take a step back, in order to understand those trade-offs between a small model and large model, it's useful to spend some time thinking about how you evaluate models in the first place. So we actually spend a lot of time what we call testing and evaluation, trying to
Mhm.
find real-world examples of how these models are going to be used within an AI application, so you can test the overall performance of the application rather than just relying upon a synthetic benchmark or an academic benchmark, something that's been published in a research paper. So even for this specific example, there are lots of great academic benchmarks on translating natural language to SQL or generating efficient SQL queries. And those benchmarks are all really useful to test against to see how the model performs in a wide variety of scenarios. But when it comes to real world use cases, there's often specific aspects of how you're using these models in a business or an enterprise that are really hard to test just using those public benchmarks. You may have a schema that's much more complicated than what the public benchmarks have ever tested before, or you may have that schema revolving around a particular type of transaction. It needs a lot of specificity around how to understand that transaction, and the real world benchmarks don't, or what you see in the academic benchmarks don't match up to that real world use that you're seeing. So we spend a lot
Mhm.
of time translating those real world uses into benchmarks that you can use to evaluate the models and understand better what are the trade-offs you're seeing in real time. So once you do that, you can start to see what the choices are between a large model and a smaller model. You may find with a large
Interesting.
model, it's capable of a lot of prompting. You can construct a
Mhm.
pretty complex prompt. And you can get better and better performance and offer more context over time. And especially today with some of the newer, larger models, they have very large context windows. So you can provide a huge amount of instructions and a huge amount of examples to the model, and the model can start to make decisions based upon maybe thousands of examples of past queries that you need to look at. And so that's an incredibly powerful technique that you can use, and you can spend a lot of time on that to make that work well. But you may see with the smaller models, you can actually do some fine tuning and get pretty comparable performance if you know exactly what the real world examples are that you're trying to fine tune the model for. And that ends up being very powerful as well. It means you can do more efficient inference. You might get faster results back from the model. You can control your costs around inference by deploying the model where you want to deploy it. And the model still performs very well in the real world examples that you're evaluating the model against. So oftentimes we'll see customers look at that trade-off and they'll try to make a decision. And then maybe we'll start with the large model and then try to translate into a smaller model some of those insights, given that they built out these test cases, evaluations that match up to how they expect the model to actually be used.
Very interesting. So, if I were to, put it mathematically, you essentially are taking a real life scenario and then almost converting that into some sort of, let's say, equation which says that if you have to look at benchmarks, maybe put these weights to really see how it would compare against one model. And once you have that framework, you could actually test a series of models. So in a way, you're applying, let's say, some sort of regression technique on on the real life scenarios.
Yeah, this is exactly right. And weighting is one way you can think about it. Another way you can think about it is the distribution of data that you're using to test the model. So where
Mhm.
you'd have a very biased test would be one where the distribution of the data is very skewed from what you're seeing in the real world. For example, if you were testing a model to see whether you should offer a mortgage or a loan to someone, and all of your tests that you have in production involve only people that come from one city, that might be a very skewed example of your data. You're not looking at all the other
Right.
cities where people could be asking for loans. What are the different ways in which their personal history may look like, or what sort of jobs might they have in different cities that they don't have in the city you're testing. So you need to make sure you have a really diverse distribution of data that you're using just to do the tests of the models, and then constantly
Right.
improving those tests over time. Do you have a good pipeline to translate new cities that you're launching your bank in or that you're launching your loan product in, and translating the sort of data and the distribution data there into the tests that you use to evaluate the model? That ends up being very important. And one area where we found this technique can be expanded in scope is by using models to help test other models. So we do a lot of what we call ML assisted testing. And that might be translating a lot of insights from a human expert, someone who knows a lot about how loans work at this bank, and using their feedback to understand what sort of things would they look for in a loan application, and translating that to something a model can use to scale up. So once the model gets really good at saying, well, we look really closely at the number of years that the person's been on this job before offering a loan to that person, that sort of insight you can translate to a model, and the model can scale up the wide variety of tests that it does to make sure that the model that you're thinking about putting in production actually is robust to a huge distribution of data, or different scenarios where someone maybe presents and isn't biased or skewed by certain aspects of the data that are irrelevant, like, let's say, the name of the person, or maybe how old the person is or where they went to school, and focuses on the things that are really important to make a loan decision.
Interesting. And for each of these two approaches, are there any specific papers or research material which is out there which someone can look and refer to?
Yeah, there's a great white paper. I'll send you the link so you can include it. But we wrote a white paper about a year ago on test and evaluation, and we focused on this hybrid approach to evaluating models. So incorporating
Hmm.
both machine learning assisted testing, having large models that we train that help test the models, alongside human experts that provide their own expertise and understanding how the model works. And we find the combination of the two works much better, especially on issues of bias. A human can sometimes recognize that a model is making decisions on certain biased aspects of the data in a way that's still pretty hard to do, given the model doesn't have enough knowledge about the human experience in the world to understand a lot of issues that come up. So having that combination of the two work well is something that we wrote about in the white paper, and it's part of our vision for how test and evaluation should work going forward.
Great. That actually is a good point to talk about your talk at GTC, which was, about red teaming, RLHF, and then frameworks for responsible AI to essentially make sure that the models work as intended. So can you elaborate a bit about the talk? What were the areas you kind of talked about, and what are some of these techniques which you think would become more and more important going forward?
Yeah, of course. I'll explain what the GTC conference is first. So GTC is a conference put on by NVIDIA, which is the world's largest, most important GPU maker. So it's a conference that attracts a huge range of people from different backgrounds. Some people use NVIDIA products because they're building simulations to build new cars and test those cars in different environments. Others are using GPU products in order to do a lot of predictive analytics. But increasingly, as GPUs have become very important for training large language models and foundational models, it's become a really important conference for everyone working in generative AI. And so our talk this year was on the work that we do around training models to get better at issues of factuality, bias, and accuracy. And all three of those are really important things that we look at as part of testing and evaluation. So one aspect is factuality. If you ask a large language model to give you an answer to a specific question, like explain to me tax laws around building a zoo in India. That might be a very specific question where you want to see specific regulations that have been written in India about zoos and what sort of animals you can keep in a zoo and how you apply for a license to open a zoo. And so having factual answers ends up being very important. And there, we spent a lot of time thinking about how you can ground the answers of model. So grounding is a specific term that means if there's a sentence or a couple words in the answer that the model gives you, you're able to tie that back to a specific document, whether that's a document on the web or an internal report or some other document that led the model to giving you that answer. So RAG ends up being a really important technique to understand grounding really well because you're passing in those documents directly to the context window of the model. And you should expect the model to be able to accurately tell you which of those documents led it to give you that specific part of the answer. It's not something that happens out of the box, and it's not something the models were pre-trained to do.
Yeah.
And so this is kind of an evolving field that we spend a lot of time on. How do you effectively ground the answer and then maybe get feedback from a human expert where the model gets it wrong? It states something about zoos that it maybe saw in the past in a blog post or something else, but it wasn't applicable to India. It was applicable to another country. Or maybe it didn't cover the type of animals that you were asking about. That sort of inaccuracy ends up being something that we have to spend a lot of time tracking. The second pieces of the talk were around bias and accuracy, and those are also really important as well. I think we spent some time talking about bias when you evaluate the models. That's really where we start. We try to find a good, robust distribution of data to evaluate the models on, so that the model is able to adapt to a wide range of scenarios, and you understand which scenarios it underperforms on. So you could say your model is able to offer a lot of answers about zoos, but it actually doesn't know that much about legal backgrounds or legal perspectives on whether you should open a zoo. In those cases, you may want the model to actually tell you, I don't have the right data to answer your question, but these are some follow-up questions you could ask, or these are places you could go to get the right answer. Sometimes that sort of answer ends up being really important for the models as well. So we spent a lot of time on that. And lastly, we spent some time talking about how you can steer a model in adopting different choices about how it answers a question. So steering is a technique that we partnered with NVIDIA on, and we have a paper called Steer LM. And this is really a technique where you can train a model to adapt to a wide range of scenarios. So in one scenario, you may be talking to a student in high school. You may be telling them some answers about zoos that's relevant to them, but they don't know a lot of background about legal answers or other questions. They just want a pretty straightforward answer. But you can imagine another scenario where you're talking to a legal expert and they're asking the same question about zoos. And the model needs to talk much more differently. It needs to use formal language. It needs to be precise in the language it's using. It maybe needs to write a longer response with multiple paragraphs to help that legal expert understand the issues at hand. So the idea that you can train one model to steer in different scenarios and have different choices about how it's going to deliver its output in those scenarios is something that I think is becoming an emerging technique, especially for the larger models, so they can react to a wider range of different ways they may be asked a question and different sorts of people that may be asking those questions.
Interesting. And in your experience, how much can this control the hallucination problem? Because you're in a way doing all of this to reduce the rate at which these LLMs can come up with answers which are not, let's say, pointing to a specific document or a data set. So what sort of reduction have you seen by applying these techniques?
Yeah, that's a good question. So the hallucination problem is still a problem today, and it's still going to be a problem for many years. And the reason is
Yeah.
that even though the models have become much better at understanding the human specificity around questions and specific domains that we've seen over the last year, the models have also started to become much more capable in new domains and new types of ways in which human beings can answer questions. And as the models expand their capabilities, we're starting to see issues with hallucinations in newer frontiers that those models are pursuing, or more complex prompts that human beings may answer questions in. So, for example, you may have a model that a year ago was making errors in basic questions about history, like when did astronauts first land on the moon? But today, that model is probably able to get those answers more accurately and actually able to reason better about history and timelines. But then, if you ask a more complicated prompt around that, like create a graph of all the times human beings landed on the moon, you may start to see the models capable of generating a graph, which it wasn't a year ago. And that graph is actually a really useful visual technique. But now the model may
Mhm.
start to make inaccuracies on certain data points in the graph rather than the answer that it gives you directly. And so you have to have much more precise evaluation of the models and understanding whether the entire graph is accurate. Is every year on that timeline correct? Is every point on that timeline correct? Otherwise, even just being off on one point on the graph the model's rendering could lead a college student or a high school student to think, oh, that we landed on the moon in the year 2012. And actually, no, we actually haven't landed on the moon in that entire decade. So understanding where those inaccuracies can come from and new capabilities, new model outputs is something we're spending a lot of time doing. We've also spent a lot of time thinking through ways where you could prompt the model with more complex prompts, which is really what you're doing when you're using RAG and other techniques in the enterprise. You're offering a lot of context to the models. Those contexts can be presented in different ways, and each of those can lead to hallucinations in how the model delivers its output if it's not presented in the way the model understands. So a great example of this might be if you're asking a question about stock prices, like let's say, what's the stock price of Google today compared to 3 years ago? And you provide a lot of research on the ways in which Google stock price might be moving in the future. The model can get easily confused if the first example you pass in is an article that was written 10 years ago about Google. They may think Google stock price actually is the same as it was 10 years ago, in part because you didn't give the model enough context to understand, hey, this wasn't written today, it was written 10 years ago. And whatever stock price you see in this article, you shouldn't interpret that as the stock price today. So that's sort of ways of thinking about how RAG leads to the model being confused or needing more instructions in order to understand how to incorporate that data into its perspective of the world is something we're spending a lot of time on as well.
Interesting. So, let's say, you're talking to a potential client or organization who wants to invest and build products on LLMs and generative AI, right? And then there are obviously some great use cases, but they come with these challenges, right? So
Mhm.
what are some of the uh, frameworks or good practices or ways in which this client can think about so that they can you know obviously start the journey but also be aware about how to navigate this, because there's a landscape which is almost changing day on day, and then it could be at times difficult to navigate this.
Yeah. In the enterprise, and this may be a surprising answer, but one of the best places to start the journey is actually a place where often people think the ending of the journey belongs, which is really think about the responsible deployment of AI. So when you get to the
Hmm.
end of this process and you've built a model, what does it mean to actually responsibly deploy that model? And we spent a lot of time talking to customers about a responsible AI framework that's actually much more grounded in data. So the data needs to really be informed by testing and evaluation of the models and having real world tests of how the model is going to perform, as well as covering a lot of issues around bias, accuracy, all of which means that you need to start thinking when you start building this application, how the application is going to actually be used in the real world. Who are the intended users? What are they going to be told about how the AI was involved in the sort of data that they're seeing? And how can they use that in order to make the right decisions? So to go back to the example of a data analyst seeing a model giving it a more efficient SQL query that the analyst could run in production, how's that data analyst being told that that model made that decision? And how should the data analyst be told about whether it should just he or she should just be running that SQL query directly, or should they be looking at that output, incorporating that alongside other things that they're doing as part of that query? All of those are really important to do as part of a responsible AI framework, a framework that takes into account how the application is being developed, how it's going to be evolved in the future, and really how human beings are going to be using that AI product and what they think about how the AI came to its decisions. So once you think about it from a responsible AI lens, you can think through a lot of different aspects of how the model should be fine-tuned, how you should build an application around it, what sort of reporting you need, and how the model is being evaluated, and then how often you should be looking at that reporting. So now we're starting to see a lot of enterprises start to have new job titles that didn't exist before. And the most new job title is one of having a chief AI officer or even a chief AI ethics officer. And for those sort of roles, we see it's really important to have a single report that you kind of can look at every day, where you can see how you're doing on testing and evaluating your Gen AI applications across the entire enterprise. Are you building new tests? Are those tests really robust? How are the models performing over time? Are they improving in their performance? Have you checked those reports before you've deployed new versions of your application to production? That ends up being kind of the critical piece of reporting that this role needs. Kind of comparable to the way data science had evolved over the last 10 years, where people take a lot of look at what sort of queries are being run in their data lakes, who's writing those queries, and how can we evolve and make more efficient the process of creating queries in the past. Now with generative AI, we're spending a lot of time thinking about testing and evaluation and who's creating those tests and whether those tests have a lot of real world experience applied in their creation, and then how the models are performing in real time.
And from you know almost putting trust in these products and applications, how do you see that panning out, right? So today, when enterprises build these products, obviously, you do a lot testing to try and ensure, but there is, you need some time to see the performance of these applications and then finally trust them and share them out. So the question is, how do you see this evolving over, let's say, next few years? And do you see this happening naturally and organically, or there are some challenges which you think would need a research breakthrough going forward?
Yeah, that's a great question. So I think the current state of AI development is definitely progressing very quickly. And we are seeing on the large closed source model size some new models being trained with a much huger range of different types of data that they can be trained on. What's called multimodal data, image, video, audio data. The original generation of these models, what you saw with ChatGPT and the first releases of Anthropic, they didn't have very many multimodal capabilities, and so they were trained on just text data. But newer models today are trained on a huge range of data that goes beyond just text. And the models have a lot more understanding of the world around them as a result of that. They can read through charts and graphs that are written in research reports, and they can understand how that relates to the text around the report. So all of that, it makes the models much more powerful, but also much more suitable to a huge range of real world use cases compared to the models in the past. Even for things like RAG, you can start to build RAG pipelines where charts and graphs or visual data or images are incorporated alongside the text data, and the models are able to understand and connect the dots about how that works alongside the text data that you see. So for those reasons, there's a lot of kind of core development that's happening right now using new model capabilities that I think is going to continue beyond without requiring like any large research breakthroughs. But at the same time, there's a lot of really important research happening right now that may fundamentally change how we work with AI and AI applications. We're seeing some approaches to using techniques that go beyond transformers. So transformers and the intention mechanism was the core building block of a lot of the models that we're using today. It means that you're able to look at a huge number of words that are passed in the context window and understand which ones are relevant to constructing a given word in the answer. But there are newer mechanisms that maybe don't rely upon attention and maybe can pass in data that was received earlier in the context window in a compressed format that can go all the way towards the next word that you're writing, even if that happens a million words into how you're writing the answer or how the number of documents you're passing in. So with those techniques, you may even see infinite context windows. You could pass in an enormous range of documents into the model and expect to get really interesting answers as a result, and maybe even checkpoint the state of the model and then use that for many, many answers over time. I think with those new techniques, you're going to see new formats of applications, new ways of thinking about what's called maybe the memory of the application, and just new ways of building an architecture around that so that you have a model that's both really general purpose and able to answer lots of questions about lots of different types of data, whether that's text or image or audio, but is also able to be specifically tuned to different scenarios using that range of insight that's there.
And in that direction, do you see RAG becoming less relevant, or there would still be applications where RAG is actually a better way to solve the problem?
That's a great question. I think the honest answer is no one really knows right now. And there's some really intriguing results. I think if you look at Google's latest Gemini paper, they've been improving the performance of their Gemini class of models over time. And one of the most recent releases, the 1.5 release, they had a really interesting research paper insight. And it was a language that they wanted the model to understand, which was pretty rare. There weren't very many examples of this language on the open web. And so they couldn't just pre-train the model on a huge number of documents that you could translate from that language to English. But they were actually able to give the model a giant dictionary that just translates word by word, one word in that language to the English translation. And given that dictionary, the model was actually able to translate documents from that language fluently into English without ever having
Oh,
seen an example of that language in the pre-training data. So that's maybe an example where you could do a huge range of things by just giving the model instructions, really complex instructions in the context window, and leveraging the fact that it's a really long context window to provide a lot of just really interesting specificity there. And that maybe will change the future of RAG going forward. But there are other reasons why we think RAG is going to continue to be an important technique to spend time adopting and evolving. One is that there's a lot of metadata around the data that we're retrieving that ends up being really important to getting the right result from the model. For example, the times that documents were created or the cause and effect. Did something happen in the past that led to something happening today? Having the model understand the connection among all the data that you're passing in ends up being really important. And if you don't provide that to a model, it doesn't matter how much context window that you pass in, the model is probably not going to see the connection among all those points of data. So we think evolving the RAG technique is going to continue to be an important research area, an area for us to focus on. And we see that demonstrated through testing and evaluation of models. The more time we spend thinking through the right embedding, the right retrieval strategy, the right re-ranking strategy, the right way to prepare this context for the model, the better performance improvements we see through testing and evaluation. And some specific examples, we've seen testing and evaluation for one task, a natural language to SQL task, where we went from a baseline performance about 14% in terms of whether the model was able to give an accurate answer when translating it natural language to SQL, all the way up to 90%, just by changing aspects of the RAG pipeline, whether it was the embedding, the re-ranking. And just by doing that alone, the model is able to better understand what it's being asked to do and give more accurate answers. And I think seeing those like really big wins and gains that we see from focusing on RAG means that we're going to be spending a lot more time on this technique going forward, regardless of the size of the context window.
interesting. And specifically for testing, do you see libraries, say, equivalent of what Lime used to be in machine learning context, that you could almost use that to generate a summary on any of these models, or something like that coming out in future?
Yeah, Lime was really important for interpretability in a lot of past generations of machine learning. One of the big challenges we have with GenAI right now is that interpretability and explainability are still very hard to do. Where we have a model that maybe is doing multiple steps of reasoning to get to an answer. So it's actually interesting right now. One of the things we focus on, especially with larger models, is helping the models think through problems step by step rather than just jumping to the
Hmm.
answer. And additionally, sometimes asking the model to go and do what's called tool usage. So this may be where a model goes and does a search against a search engine, or goes and calls a statistics package to get a statistics answer, because the model knows enough to know in order to get the accurate answer to this particular step in the problem, I need to go and access an external tool that I don't have, I'm not able to do just within my memory right now. So helping the model think through those two aspects ends up being really important. those both also open up a lot of options for interpretability of the models. If you ask the model to break down step by step into 10 steps how it came up with the answer to an arithmetic problem, you can go back as a human expert and say, well, the model got it wrong at step 5, and this is a possible reason why. And you can explain to the model, even in natural language, this is how you would get an accurate result, and this is how you should rethink the problem. Over time, that can become a really important source of data for fine tuning the model so it gets more accurate. The same thing goes hand in hand with tool usage. If the model goes and does a Google search to look up what sort of cities in India are where the most loans are happening as a company, and then it gets the wrong answer back because it didn't search against the right store, giving that feedback to the model and telling the model, hey, you should go look for this data in a different location next time. That ends up being something that's really important to fine tune the model on. So we're seeing a lot of interest in those kind of two capabilities paired together. And that means really sophisticated testing, evaluation, and the ability to give feedback to the model at just the right moment. And it helps you interpret and understand what the model is doing better in the future. But right now, it isn't really a general purpose package. These are a range of techniques that are becoming just known this year. And so we're hopeful there's a lot of interesting research direction happening. We're excited to publish more results, too, about testing and evaluation we do in this area.
Great, great. And we've talked about a range of topics and what's happening. Uh, what are, let's say, the top 2 or 3 trends which excite you the most about what's happening and then what is going to happen in, let's say, next couple of years?
Yeah, absolutely. I would say that the top two definitely, the number one for me would be the rise of agents as an AI architecture.
Mm-hmm.
And so agents is just a fancy way of saying that you have multiple models communicating with each other and sharing some aspect of what tasks or problems they're being asked to do with each other in a way that a group of different models can work together to answer a problem. Those could all be from
Yeah.
the same family of models, or it could be a large model talking to multiple smaller fine-tuned models.
So,
But it's the coordination
mhm.
among all those models that ends up being very powerful. And in some ways, agents is an evolution of what I just talked about, the working step by step and using tool usage, but evolving it in a much more broader direction where potentially you could have thousands of different requests being made to different models, each kind of focusing on a different aspect of the data or how you construct that data and getting back really sophisticated answers. You could imagine in a question about when did moonlightings happen, you can have multiple models going and checking the dates of each individual event and then individually sharing that back in a table and then using that table to plot out the answer in a way that you're double checking at each point whether that data is accurate or not before you get the answer back to the human. And it turns out if you do that, you're much more likely to get an accurate answer. And you're also able to check the work. You're able to see intermediate steps going along. So we're seeing a real interest in agents being able to do a huge range of work and parallelized work across a range of different data types. And I think that's going to be a really important kind of the thing to tackle. It comes with really challenging infrastructure requirements because now instead of just a single model that you're prompting and getting an answer back in, let's say, 2 seconds or 3 seconds, you might actually ask 1,000 different models and over the course of 30 minutes get different perspectives on that. You might have multiple pipelines set up to flow data from one model to another. Some of that can be done in parallel. Other needs to happen step by step. It may be really hard to predict upfront which of those is going to happen, given it may be a very large general purpose model just constructing this plan itself. But we're seeing a lot of interest there because this is a great way to get more accurate answers, much more sophisticated answers out of models, and work with much more complex data types and data structures than we have in the past, especially for domains like coding, where you can do a lot with agents that wasn't really possible just by asking the model to generate a code snippet by itself. So I think that's going to become really important. And then the second answer I would give you is probably just coding in general. I think is becoming a really important
Mhm.
area to focus on. We're seeing models that a year ago we were focused on just a single answer that model would give to a coding question. Help me write
Mhm.
an iOS application, and the model would give like a pretty close to accurate answer, but often far enough that you'd still have to spend an hour, 2 hours as a developer using that output to actually make it useful to you.
Yeah.
But now I think with agents and other architectures, we're starting to see much more sophisticated ways of getting that insight out of the models. And we're seeing a lot more great outcomes for developers using those more sophisticated techniques.
Very interesting. Very interesting. Uh, One of the aspects which we haven't touched as much till now about your journey is, entrepreneurship and your role as a scout at Sequoia Capital. So, So right now, when act as a scout at Sequoia Capital and find those next innovative startups, what are you looking for, and what do you emphasize on when you are, let's say, evaluating a startup?
Yeah, it's a really interesting time for generative AI in particular. And also with my role at Scale, we often get to work alongside a lot of really interesting startups being part of the ecosystem. For example, there's a whole category of startups that are building vector databases, which wasn't really
Yeah,
a category, 5 years ago, 6 years ago. I know
right. Mhm.
during my time at Apple, at Google, we were obviously interested in vector database approaches, but we didn't have like a standalone product. And now there's a lot of sorry, it cut off a little bit again. But there's a lot of interest in
Yeah.
standalone startups, for example, those that are building more powerful vector databases or those that are doing it much more efficiently, and different ways of incorporating different types of documents. Those could be really large PDF documents, or it could be research reports. Some of those could have charts and graphs and other things, incorporating that into a database. So this one category has started to become really important and really huge, and it's been really exciting to see that. I would say for any startup starting that's thinking about a Gen AI product, really important to focus on how that application or product is going to be used in the real world, rather than just starting with what you think is the most interesting thing for Gen AI to do. We see a lot of
Mhm.
excitement where people are building products that solve real world problems and that different companies can use or that different developers can use. And when you can demonstrate that you're adding value to people on day one, rather than just building something that's abstract or something that could be used in the future, but you're not quite sure how. That's, I think, where the sweet spot is right now. Because from there, you can learn a lot from users and you can adopt a wide range of different techniques to build your application in the future. But starting with something that focuses on a user problem, addresses that problem, gets a lot of feedback from users. That's really the important area to start right now.
Interesting. And I think that's one of the traits which has actually increasingly become more important because the pace at which, let's say, LLMs are evolving, you can't really do a future play as much in terms of, you have to be clear about the problem you're solving. As I guess the importance has increased compared to maybe a few years back.
Yeah, I think that's right. The space is moving so quickly, and the models are becoming capable along a range of different domains and areas in a way that they weren't a year ago. That it's really important to focus on the problem you're solving and how quickly you can adapt to new changes in the underlying tech or the underlying foundation models you're using. Those companies that can react really quickly to change and a fast pace of change are the ones that I think are going to win.
Interesting. And any specific startups or kind of startups which you are most excited about, or what kind of problems, let's say, you would love to see getting solved in next 3 to 5 years?
Yeah. One of the things that we really love is our background at Scale. We've been working with multimodal data for a long time, since the history of the
Mhm.
company. Our founder, Alex, started it by looking at really important computer vision problems and self-driving and building self-driving cars that can stop when there's a pedestrian at a crosswalk. What does it take to build models that can hit those safety milestones? So I'm very excited about kind of the future of how those techniques can be used now in this new Gen AI phase where we're seeing new foundation models built that can work with vision data. And then in the future, those models may be able to power robots and robotic arms and the ability for robots to work alongside humans using the same foundation model principles that we used for text generation and for work with images and audio data. So I'm really excited for those embodied agent startups that we're starting to see. And that might actually be the next really important source of how we train models, how we have models that understand the world around us. And might be models that are able to work in the world around us and work on tasks, like having a foundation model that trains a robotic arm to wash dishes. And it turns out that's a really interesting way to learn a lot about computer vision problems, to learn a lot about different types of materials, how you might pick them up delicately with the arm, how you might use soap to wash the thing accurately. All of that is a really important research area to start to bring some of our thinking around foundation models over to this new domain. So I think given our background in computer vision, a lot of work we've done in robotics over the years, we're really excited about that going forward too.
Great, great. And just last question about let's say people who are starting their career in AI ML, this now feels like a place where you have to do a lot of catching up, or you have to really learn a lot before you could, let's say, start impacting and solving problems. So, any particular advice about how should they think about their career and navigate their journey in AI and ML and generative AI?
Yeah, absolutely. We often hear from people they feel a little overwhelmed right now that there's so much research being
Hmm.
published every week. The large research labs are publishing research papers almost every week now. We're also seeing just huge amount of interest in the open source community and new models with new capabilities published every week. That makes it really difficult to try to keep up with what's happening. I would say focusing on kind of the fundamentals of what you need to know in order to stay ahead. How do you go about testing and evaluating models? How do you build pipelines around models? How do you build AI agents if you're building, if you're interested in AI agents? And really focusing on what are the fundamental truths of that field ends up being a great place to start. And from there, you can start to have a filter about what sort of research is relevant to you. How do you find that research? How do you think about maybe one or two research papers per week that are really interesting and relevant to you that you can read through? That building that practice, I think, ends up being really important to try to stay a pace of what's happening in the world right now. And I think, honestly, education around AI is something that's going to be really important going forward. It's something my wife focuses on. She has a startup called UpLimit that's dedicated towards AI education. I think in the future, you're
Hmm.
going to see a lot more people interested in how can I stay ahead of this field? How can I stay up to date with what new techniques are out there? And how can I do that using all of this stuff that maybe is important in my day job, but also is important in what I see my job being, 3 years from now, 4 years from now, given how quickly the models are developing. For example, if I'm a data analyst, there might be some techniques I can use today to help me assist in doing the data analysis queries I'm doing. But I might also think about the field 5 years from now, where I might be using models as just a core part of everything that I do. So spending time thinking about those two different perspectives is important to everyone, I think.
Sure, great. Thanks for sharing that, Vijay. And usually, towards the last few minutes of these conversations, we just do a rapid fire round with our guests, and the idea is to just know you better as a person.
Mhm.
My first question would be: how does your typical day look like, and then where do you slot your own reading time, and how do you keep pace with the industry?
Yeah, that's a great question. I have two young kids, so my day often starts with just waking up my kids and then immediately
Mm-hmm.
getting them breakfast. But almost immediately, I usually see on email or Slack or on or other forums that Discord has been a really important way of sharing insights with the research community. Like one or two research papers per day that I want to spend some time understanding. And I often start my day with just looking at what's happening in those papers and why is that relevant to what I'm doing. It's a great way to get started and feel like your day's starting with the forward progress that's happening in the community right
Mm-hmm.
now. And sometimes one of those insights is important the rest of the day. Other times I just have a useful thing in my back pocket that I may use weeks from now or months later, given how quickly things are evolving.
Interesting. And what does your weekends look like?
Yeah, our in San Francisco, one of the things we're really lucky to have is a lot of great places to explore. This is kind of the heart of the AI revolution, and so you can go out
Mhm.
and go hiking, and you might run into a researcher that you met years ago. So I really love getting to explore the area around here, and also getting to be alongside a lot of great researchers, people just starting their careers, getting to meet them on weekends too.
Interesting. And any particular books which had huge impact on you and how you think?
Yeah, when I was growing up, there was a book called Artificial Intelligence Techniques that was specifically about kind of neural networks and how neural networks could be trained. I'll look up the book title and I'll send it to you. But having
Mhm.
books like back in the 90s ended up being really important because you would have to get pretty much all your insight from reading a book. There wasn't anything on the internet that people were writing that they were sharing that you could easily use to find things out. So that book ended up being really fundamental to what I used.
Great. Thanks a lot, Vijay, for your time and sharing those insights, interesting trends, and some of the challenges about working with these generative AI applications. Thanks a lot for sharing those.
Great. Thank you, Kanal. Really excited to chat with Leading with Data and really excited for the future of this field.
Thank you.